chapter Factors and Multiples for grade 5 and 6. Topic Divisibility Rules. Hello everyone. In this video, I will be explaining divisibility rules. These rules help us to find out whether the given number is divisible by 2, 3, 4, 5, etc. without actually dividing it with that number. So it helps us to save time. First divisibility rule is for 2. The rule is if the digit at one's place is 0, 2, 4, 6 or 8, any one of these digits is present at one's place, then that number is an even number. An even number is completely divisible by 2. This we will understand with the help of an example. Suppose the given number is 754. The digit at one's place is 4. So here the number is an even number. An even number is completely divisible by 2. So 754 is completely divisible by 2. To confirm this, we will divide 754 by 2. When we divide 754 by 2, we get the answer 377 and the remainder is 0. That means this number is completely divisible by 2. One more example we will see. Here the number is 567. The digit at one's place is 7. That means this is an odd number. An odd number is not completely divisible by 2. So 567 is not divisible by 2. This we will confirm again by dividing it by 2. When we will divide 567 by 2, 283 is the quotient and the remainder is 1. So remainder is 1, that means it is not completely divided by 2. Next we will see divisibility rule for 3. The rule is if sum of all the digits is divisible by 3, then that number is divisible by 3. Here are 3 digits. Sum of all these 3 digits, that is 3 plus 8 plus 1 is equals to 12. And 12 is divisible by 3. That means 381 is completely divisible by 3. This we will confirm by dividing it by 3. So when we will divide 381 by 3, the quotient is 127 and remainder is 0. So 381 is completely divisible by 3. We will take one more example. 436. When we will add all the digits 4 plus 3 plus 6, the result is 13. 13 is not divisible by 3. That means 436 is not completely divisible by 3. This we can confirm by dividing it by 3. When we will divide 436 by 3, we get the quotient 145 and the remainder is 1. So, 436 is not completely divisible by 3. Next divisibility rule is of 6. If the number is divisible by both 2 and 3, then the given number is also divisible by 6. For example, 846. This number is having 6 at its ones place. That means it is an even number, so it is completely divisible by 2. Now we will see if it is divisible by 3. So we have to add the digits of the number. 8 plus 4 plus 6 is equals to 18. And 18 is divisible by 3. That means 846 is also divisible by 3. If it is divisible by both 2 and 3, it is also divisible by 6. This we will confirm again by dividing it by 6. When we will actually divide 846 by 6, we will get 141 as a quotient and 0 is remainder. So that means 846 is completely divisible by 6. If the given number is divisible by 2 and not by 3, or if it is divisible by 3 and not by 2, then that number is not divisible by 6. The condition is that the number should be divisible by both 2 and 3, then only it is divisible by 6. Now we will take one more example to understand divisibility rule of 6. The given number is 754. 4 is present at its ones place, that means the number is an even number, so it is divisible by 2. Now we will see if the number is divisible by 3. For that, we will add all the digits of the given number 7 plus 5 plus 4. So here the total is 16. 16 is not divisible by 3. That means 754 is not divisible by 3. That means the number 754 is not divisible by 6. As I told you that the number should be divisible by both 2 and 3, then only it is divisible by 6. Otherwise, it is not divisible by 6. This we will confirm by dividing it by 6. When we will actually divide 754 by 6, we get 125 as a quotient and 4 is the remainder. That means 754 is not completely divisible by 6. Next divisibility rule is of 9. It is similar to 3. The rule is if the sum of all the digits is divisible by 9, then the number is divisible by 9. For example, 1629. If we add all the digits of this number, that is 1 plus 6 plus 2 plus 9, then we get 18. And 18 is divisible by 9. That means 1629 is divisible by 9. This we can confirm it by actually dividing it by 9. When we divide 1629 by 9, we get 181 as a quotient and remainder is 0. Next we will see divisibility rule of 5. It is very easy. You might have observed 5 table. Then we can see there is 0 and 5 alternate in the 5 table. So if one's digit is either 0 or 5 in a number, then that number is divisible by 5. If the given number is 175, then 5 is present at its ones place. That means 175 is divisible by 5. If we will actually divide 175 by 5, quotient is 35 and we get 0 as the remainder. That means 175 is completely divisible by 5. Next is divisibility rule of 10. If one's digit is 0, then that number is divisible by 10. If you have observed tens table, it is 10, 20, 30, 40, 50 and so on. That means always there is 0 at one's place. So if any number is having 0 at its one's place, then that number is divisible by 10. For example, 2940. So here 0 is present at its ones place. So this number is divisible by 10. If we will actually divide 2940 by 10, we get 294 as a quotient and 0 as the remainder. Next rule is of 4. If the number formed by tens and ones place is divisible by 4, then that complete number is divisible by 4. For example, this is a 5-digit number. 3 is at tens place and 6 at ones place. So it forms 36 at tens and ones place, and this 36 is divisible by 4. So this complete number, that is 96736, is completely divisible by 4. If we will actually divide 96736 by 4, we get 24184 as the quotient and 0 as the remainder. Next is divisibility rule of 8. If the number formed by hundreds, tens and ones digit is divisible by 8, then that complete number is divisible by 8. Here is a 6-digit number 987816. So first we will see if 100, tens and ones place digit, that is 816, is divisible by 8. So if we divide 816 by 8, we get 0 as the remainder. That means it is completely divisible by 8. So this 6-digit number is also divisible by 8. So here when we divide 987816 by 8, we get 123477 as the quotient and 0 as the remainder. That means this number is completely divisible by 8. Next is divisibility rule of 7. Double the last digit, that is digit at its ones place, then subtract it from the number formed by rest of the digits. After subtracting, the answer which you will get, if that is divisible by 7, then the complete number is divisible by 7. We will take this example 672. The last digit is 2, that is at ones place. So we will double the digit at ones place. So it becomes 2. Double of 2 is 4. We will subtract 4 from rest of the digit. Rest of the digit means 67. So we will minus 4 from 67. So we will get 63. 63 is divisible by 7. So when we divide 672 by 7, 96 is the quotient and 0 is the remainder. Next divisibility rule is of 11. For this, we have to understand odd and even places. We know that 1, 3, 5, 7, 9 are all odd numbers, and 2, 4, 6, 8, these are all even numbers. Here we have to remember only odd and even places, not the numbers. So 1 is a odd number. So we will remember that the first place will be the odd place. So the first place from left hand side will be the odd place. So the alternate places like first, third, fifth, seventh, ninth will be the odd places. 2 is the even number. So we will remember that second, fourth, sixth and 8 will be the even places. So here, consider the first place from left of a number as an odd place. Consider the second place from left of a number as an even place. So one will be odd, then even, odd and even. So we say that alternate places are odd and even. Next step will be, we have to add all the digits present at odd places. Then next we have to add all the digits present at even places. Then find the difference of the sum of the digits at odd and even places. If the result is either 0 or 11, then the number is divisible by 11. This we will understand again with the help of an example. The number given over here is 461857. So I have written it with two colors so that we can understand that the first place from the left is a odd place. So here 4, 1 and 5 are present at odd places. So the digits at odd places are 4, 1 and 5. So we will add 10 and we'll get the result 10. Next is even places. Digits at even places are 6, 8 and 7. So we will add 6, 8 and 7. The result will be 21. When we will subtract 10 from 21, that is 21 minus 10, we get the result 11. So this number, that is 461857, is completely divisible by 11. This we can confirm by dividing the number by 11. If we divide 461857 by 11, we get the quotient as 41987 and remainder 0. The remainder is 0, that means the number is completely divisible by 11. I hope the topics discussed in this video are clear to you. See you in the next video. Till then, goodbye.